Live on YouTube.
I don't think it's live.
I'm going live on YouTube.
Okay.
I'm filming this video.
You're gonna have
live
to cut this
in
out.
person. What?
You're gonna have to cut this out.
Why? Why can't I leave this in?
Okay, leave this in, please.
All right, we're going live on YouTube
You're messing up the video.
now. Oh, cucumbers. I already taught with a cucumber. All right. We have a piecewise defined function that we want to find the extreme values of. So, first thing we need to do is look at the domain. What's the domain of our function? We got x is less than or equal to 1 for this one. Are there any restrictions on 5 minus 2x squared? No. Are there any restrictions on x plus 2? No. Does x less than or equal to 1 and x greater than 1 include all real numbers? Yes. So our domain, oh, this is not working as well as it was before. There we go. My fingers were too close to the board. Much better. Our domain is negative infinity to infinity, but we have potentially something weird happening, some sort of discontinuity or something at x equals 1. Right? We have something weird happening at x equals 1. So we're going to have to investigate what's going on there. No endpoints. So no endpoints to check. All we have to do is find the critical values. So how do we find the critical values? Derivative. See when the derivative is 0 and when the derivative is undefined. So for values of x that are less than or equal to 1, what does f prime of x equal? Negative 4x, right? Derivative of 5 minus 2x squared. So when does that equal 0? It equals 0 if x equals 0. And when is it undefined? When is negative 4x undefined? Never. Okay. So does this critical value of x equals 0 fall within this piece of our domain? Yeah. 0 is less than or equal to 1, right? So this is one critical value that we definitely have. All right. Now we have to do it with the other piece. This grape is smaller. Let's see how this works. If x is greater than 1, that's a 0. 1. What does f prime of x equal?
1.
1. When does 1 equal 0? Never. When is 1 undefined? Never. So we get no critical values from this. Everybody good with that? So we have one critical value at x equals 0. Now, we also, though, have something weird happening at x equals 1, right? We could have a discontinuity there, and we may have a place where the derivative is undefined at x equals 1. Because if the derivative from the left and the derivative from the right are not equivalent at x equals 1, then the derivative is undefined at x equals 1. So, first of all, let's see if the function is continuous. How do we determine if the function is continuous at 1? Limits. Yeah, limits. The limit as x approaches 1 from the left is what? 5 minus 2 times 1 squared, which is 3, right? And what's the limit as x approaches 1 from the right? Should be 1 plus 2, which is 3. So it's continuous, right? It's continuous at x equals 1, but does the derivative exist? Our derivative over here was negative 4x. Evaluated at x equals 1, what does that give us? Negative 4. And what about 1? Evaluated at x equals 1. That is 1. So does 1 equal negative 4? No. So our derivative is undefined at x equals 1. Everybody good with that?
Yeah.
So we also have a critical value at x equals 1. So now what? We need another grape. what do we need? We need a sign chart, right? To check and see if it's maxes or mins. What were our two critical values?
0 and 1.
0 and 1. Were there any restrictions on the outsides of that?
No.
Nope, negative infinity to infinity. So choose a value less than 0 and plug it into your derivative. If we pick a value less than 0, like negative 1, yeah? What was our derivative for values that are less than 0? Well, that'd be this one, right? So our derivative is negative 4x. If we plug in negative 1 to that, what do we get?
Positive.
We get a positive. Right? So if the derivative is positive, it means our function is increasing. And what if we plug in something between 0 and 1? We'll still use negative 4x. So put in a half to that. What do you get? A negative number. So our derivative is negative, which means the function is decreasing. Plug in something more than 1 to your derivative, like 7 or 1,000 or whatever you want. That derivative for values greater than 1 is just 1, which is always positive, which means it is always increasing. So looks like we have a local max of, well, what's f of 0? F of 0 was 5.
Yeah.
So we have a local max of 5 at x equals 0. And we have a local min. What's f of 1? 3. So we have a local min of 3 at x equals 1.